So in this class, we will do some practice problems from 8.1, and 8.1 is arc length. So the first we will do this number 11, and the question is find the exact length of the curve, and the curve is given by so we have to find the exact length of the curve from x equals 1 to 2. Okay. Now here the curve equation is y as function of x. So the formula for the length of the curve is where x is from 1 to 2. So in order to compute arc length, you can see we have to compute what is dy over dx. So let's do that. So dy over dx is now the next step is we have to square dy over dx. And for this, you should memorize the identities, which we will be using often in this section and in chapter 8. And if we have a minus, so therefore we can see what will be dy over dx squared. And we can simplify it. So this becomes the next step. If you look at the formula for arc length, so this is the formula I'm talking about. We have to add 1 to it. So the arc length becomes Note that this 1 will subtract half from it. So this becomes so 1 minus half is half. Now if you observe this identity written here, a plus b whole squared, x fourth is x squared, 1 over 16 x fourth is 1 over 4 x squared. And when we had minus here, we got a negative half, but now we have positive half. So this is same as so we have a perfect square inside a square root. So note we have a thing like this, perfect square, right? And this you can always expect in most of the problems in this section whenever you are computing arc length. So we have to cancel this square with this square root. So that will give us so always check your calculations if you are not getting a perfect square inside this radical sign. Now we can apply power rule. That gives us so first I have substituted 2 in place of x. I got 2 terms and then subtracting the 1. So we have 8 over 3 minus 1 over 3 minus 1 over 8 plus 1 over 4. This gives us 7 over 3 plus 1 over 8. So common denominator is 24. We have 56 plus 3. So the final answer is again positive. So like areas and volumes, arc length is also positive. So the length of this curve is 59 over 24. Now let's do another homework problem. This is 13. 1, 3, 13. Now the curve given to us is x equals so here x is function of y. The formula for the exact length of the curve will be now since x is function of y, so we will have dx over dy squared dy. So here we are integrating with respect to y. Okay, so first let's compute what is dy over dx or dx over dy. Let me rewrite x here as so dx over dy just by simple power rule. So dx over dy becomes y half over 2 minus 1 over 2 So next step is we have to square. So we'll use the same identities that I wrote in the previous problem. So now I'm using radical sign with halves just to remind you that both mean the same thing. Let me see if I can get more light here. So when we square it, we get using the previous identities. So last term, we can cancel out factors of radical y and 2. And this is 4. So here also we get half. Now note that in the formula for the arc length, we have 1 plus dx over dy squared. So now let's add 1 to it. You can subtract half from 1. Now if you observe, this is same as radical y over 2 squared. So note that above we had a negative half, which corresponded to the square with the negative sign. Now here we have a positive half. So this corresponds to which is so again we have got a perfect square. So it means the length is integrate y from 1 to 9. Square root. So now you see a pattern here that inside this square root, we are getting a perfect square. Now this perfect square will cancel out the square root. Now this antiderivative again we can do using power rule. So this gives us, so square root of 9 is 3 and 3 cube is 27. Square root of 9 is 3 and 1/3 plus 1 is 4/3. We get 12 minus 4/3, which is 36 minus 4 over 3. So your answer is 32 over 3. So again, the arc length is positive. So if you're getting a negative answer, check your calculations. Let's do another problem where we have some trig function. number 15. So if you have any questions, so I will have office hours via Zoom, so you can ask. So this is number 15. The question is same, find the exact length of the curve. The curve given to us is ln of secant x, and x goes from 0 to pi over 4. The formula for arc length is the curve is y as function of x, so we have dy over dx squared dx. Now here, to compute dy over dx, you should remember your Cal 1 class where we had this chain rule. It will be 1 over secant x times d by dx of secant x, which is secant x tan x, and secant will cancel out. So dy by dx is just tan x. So now if we substitute this in this formula for arc length, now if you remember your trig identity, 1 plus tan square x is secant square x. So again, inside this radical sign, we have a perfect square. So here you should remember what's the antiderivative of secant x. So here, how we used to do it. We multiply, divide by secant x plus tan x. Then make a u substitution of. So you should know how we derive this antiderivative of secant x, because if it's in the test or your exam, you should not just use the formula directly. This is exactly the numerator. So the numerator here is exactly du. So then you have okay. So now let's go back to our arc length. Which is ln of secant x plus tan x. Now one thing to keep in mind, since cos pi over 4 is 1 over radical 2, therefore secant pi over 4 will be radical 2. Tan pi over 4 is 1. Secant 0 is also 1 because cos 0 is 1. And tan 0 is 0 because sine is 0. So substituting those values, we get in radical 2 plus 1 minus ln of 1, which is so that's our final answer. So in this arc length problems, we have seen a pattern, which is inside this radical, we always get a perfect square like this. Now let's do a different type of problem, which is one of your homework problem, but it's a slightly different in a sense. Instead of calculating the arc length directly, you have to calculate arc length function. This is homework problem 35. The question is, find the arc length function for the curve y equals 2 times x3 half. So this is the curve with starting point is given to us. So starting point is P naught 1, 2. So we have to find the arc length function. With this starting point. The formula for arc length function is, so I'm writing x because the given curve is y as function of x. Because the given curve is a function of x, so arc length will also be a function of x. Starting point, P naught x is 1 here, starting point. And then because it's a function, so your final answer is the function of x, so you will integrate up till x. because x is now one of the bounds, so we something here. So if you observe, I have replaced x with a dummy variable t. So t is like your some parameter or some dummy variable. What we are doing is we are doing the same thing. So first let's compute what is dy over dx. Yes. And then we compute what is dy over dx squared. But now we change from x, we go to t. So let's just for completeness, let's write what is 1 plus dy. And note that this is positive when x greater than in the given range when starting from 1. Now we just replace x with t. So our arc length function let me change, instead of x it's t. So there's nothing to be confused here. First compute dy by dx, then take its square, add 1 to it. So once you have this 1 plus dy over dx squared, now change, replace x with t. And then go back to your arc length function. So the variable here is now t. With this antiderivative, we can do using a u-sub. So if you make u sub as 1 plus 90, on this antiderivative by this time you know. So this comes from the power rule. So this is same as 3 over 2. And then the final answer becomes so note that this is a function of x. So arc length function will be a function of x at the end. So this is all from 8.1. Next we will do 8.2.